Alright, today's video is going to be about scientific instruments and significant digits. Now, for scientific instruments, basically most people read instruments incorrectly. And so our purpose today is talking about how to read instruments. And I think the biggest takeaway from this is this slogan right here, which is what you know and one beyond. So you always read the instrument to what you can actually know, and then there's one little piece of guesswork there. So for balances, it's pretty straightforward. So there's a picture of two balances here. You can see the one here on the left can actually read to the hundredths place, 58.83. The one on the right can only read to the tenths place. So the balance actually does the work for you. And as you can see, the one on the left, this one, has more precision and more significant digits than the one on the right. And you even go with a more expensive balance. So for instance, this one right here reads all the way to 0.001. That balance is actually going to cost at least 10 times more. So the previous page, those balances maybe cost around $200. This balance here is going to cost anywhere between $2,000 to $2,500. Now, why is that? A big deal is that the more precision you get, the more it's going to cost you for that precision. Now, reading scientific instrumentations is much more difficult than just reading balances. So first off, we just have this metric ruler here that reads in centimeters. Now, what I mean by what we know and one beyond is that what we know for certain is that this item is right at least here. So we have 2.5 from this thing, 2.6, 2.7, and 2.8. So all of us, I don't care who you are or where you're from, you're going to get 2.8 for that. Now the third digit, to go from what we know, that 2.8 over here, is going to be a guess. So you might have 2.81, 2.82, or 2.83. It's fine, but any of those are all going to be significant. So to read this ruler, you should come to a reading of 2.81, 2.82, or 2.83. And again, what we know is the 2.8. The one beyond is the guess to get to the 2.81 to the 2.83. What about number 2? What I want you guys to do is look at this and determine what we know and one beyond. Okay. Well, what we know for certain is this is definitely at 4, because we see it. And then it's right here at 4.5. So what we know for certain is this is 4.5. Now we need to go one beyond. Now, to me, it looks like it's right over the arrow. So I'm not going to have a 1 or a 2 or whatnot. I'm just going to put a 0 there and then centimeters. So that's how I report that ruling, what I know and one beyond. What about thermometers? Same deal. It's what you know and one beyond. This thermometer here is reading in Celsius. So we have 10 here, 20s here. So this, where that marking is at 15. So what we know is 15. Again, it's right on that 0 point. So you would record this as 15.0 degrees Celsius. What we know and one beyond. Now why don't you guys, I actually just went through that. So again, it just walks through that we know 15. The one beyond is that there, more than likely to the 0 to get 15.0 degrees Celsius. Now why don't you guys try this example. So look at this Celsius scale thermometer. Come up, go to what you know and one beyond, and then we'll talk about it. Okay. Well, again, here's 20. Here's 30. This is 25. So we have 26, 27, and 28. So what I definitely know is I have 28. Is this line right here. Now here's 29 and it looks about halfway. So I would probably call it 28.5 degrees Celsius. But still, you could have 28.6 or 28.4. Again, that extra one is just a guess, so you might get slightly different answers, but it's always what we can read or what we can know, and then one beyond that. Alright, let's do, this is actually a picture of a beaker. So again, what we know for this beaker is going to be 30. Being it's a beaker of water, you don't read it at the top. You read it at the bottom or the meniscus, which is right here. So the one beyond, to me, would be 0.0, which would be that. You probably could get maybe 29.9 or 30.1 out of that. But again, the first two digits are what we know for certain, and then one beyond. So again, I just walked through that step over here on what we know and one beyond to get those values. Why don't you guys go and try this example right here. Again, this is a beaker of water. You want to read from the bottom of the meniscus. I'll give you a little bit of time to write this one down, and then I'll walk through it. Alright, so what we know for certain, here's 25, here's 30, 26, and 27. It's between 27 and 28, so I would probably call this 27.5. That's what I know, that's one beyond. Now, switching gears a little bit to significant digits, because again, the previous stuff, when you read things, you got significant digits. Significant digits is pretty important, particularly for chemistry, because you as a scientist are going to report numbers with confidence. And the more precise your instruments are, the more confident you are. So for instance, turning to the next slide, again I have this example here of these two balances. This balance actually has more precision and therefore has more significant digits to it than this balance. So this balance here is 58.83 grams. So we go to this extra hundreds place, where this one here only goes to the tenths. As I talked about, the more significance you have, the more expensive the balance is. So this balance here actually costs about an extra $100 compared to this one. Now the best way to learn significant digits is that a lot of books will give you like 10 rules. That's silly. You only really need to know 2. The first rule is you always draw a box around all non-zero digits. Don't care about decimal places, don't care about zeros between non-zeros, but always draw a box around all non-zero digits. The second one is if a dot is present and a dot equals a decimal point, you're going to draw a second box around any zeros behind the first box. And then all box digits are significant. So you look at this example here I have 0.01230123000. Step 1, I'm going to draw a box around all non-zero numbers. Well, my first non-zero number is this one. And then I'm going to go all the way back to the last non-zero number. So I'm going to go back, back, back. There's that 3, so I'm going to box that off. Then I go to number 2. If the dot is present, and we have a dot, there's a decimal point right there, I put a second box around any zeros behind the first. So I basically put a box around that. So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9, so this number has 9 significant digits. Alright, so let's go and do some practice with this one. So on the first one, I just have the number 10. I'm just going to draw a box around the 1 because it's only one significant. There's only one non-zero number. I have no decimal, so I'm done. This actually has one significant digit. For this one here, I'm going to draw a box around the 1 again. I do have a decimal point, so I'm going to have a second box behind the first. So this is going to have 3. So for any calculations, this top one would just have one significant digit, while the bottom one has 3 significant digits. Alright, now I want you guys to do some practice. So go ahead and pause the video right here. Work on these 4 problems and hit play again, and then I'm going to go through and walk through these. Okay, so for number 1, again I'm going to box all my non-zeros. So I'm going to box all the way back to here. I do have a decimal point, so then I'm going to box the 0 behind that and add that up. So I have 2, 4, 6, 7. So I have 7 significant digits. For number 2, I'm going to box all the non-zeros, which I'm going to go from a 1 to a 3. I have no decimal point, so I'm done. So I just add up the numbers there, 2, 4, 6, and 7. For the third one, I'm going to box all the non-zero numbers. I actually get everything. So for this one, I should have 6. For the bottom one, I'm going to box all the non-zero numbers. I have no decimal point, so from that one I'm going to get 4. This last slide here is just additional practice. So again, if you think you have the concept, you're welcome to stop now. If you want, here's 4 more items. Go ahead and pause the video and work out the 4 for how many significant digits there are. Then I'm going to go ahead and go through it. Alright, so for the first one, I'm going to box my non-zero. No decimal point, so that's 1. For the second one, I'm going to box my non-zero, which is a 4. I do have a decimal point, so I'm going to box all the zeros behind the first box, so my total number of significant digits is going to be 4. For C, I'm going to box all my non-zeros. That includes everything in the number, so that's going to be 4. And then for the last one, I'm going to box this non-zero. I do have a decimal point, but there's nothing behind this, so I'm done. And that's going to go ahead and give me one significant digit. Alright, that's the video. We will talk about this in class and do some problems to avoid homework. Thank you. And if you have any questions, you can email me or stop in.